All right, you guys were asked to take this information using the listed lemon crash data, find whatever. I added to that and I said, well, first you have this information, determine if there is a linear correlation. And if there is a linear correlation, is it a positive or negative one? And if there is a linear correlation, then give a regression equation to represent the situation. And if there is a linear correlation and you have the regression equation, now use it to answer the question. So you have a bunch of things to do here. So let's go. First thing I want to do is look at the graph. I want to look at the graph. I want to see, does it look like it has regression? A linear correlation. But actually, before I do that, I do also want to determine what would represent my x and what would represent my y. Would lemon imports be dependent on crash fatality, or would crash fatality rate be dependent on lemon imports? And for me, it looks like I would expect more crashes from cars that are lemons rather than new cars. So I would say that the crash fatality rate would depend on lemon imports. So I would call lemon imports X and crash fatality rate Y. So I'm going to put my lemon imports in L1 and my crash fatality rate in L2. So I'm going to go to Stat and Edit. And if I do have stuff in here, I'm going to delete it. So clear, enter, over here, clear, enter, because I'm going to use L1 and L2. And in L1, I'm going to put lemon imports, right? So 230, 265, 358, 480. I mean, we've done this a million times. I mean, okay, not a million, but we've done it a lot, inputting data, right? Over and over again. L2 is going to be my crash fatality rate, so 15.9, 15.7, 15.4, 15.3, and 14.9. Okay, so this is paired data. It does matter that I put them in the proper order. So L1 is my X list, L2 is my Y list, L is lemon imports, and Y is crash fatality rate. So I'm going to go to stat plot. Actually, before I do that, I don't have anything in my graph. I'm going to go to window and change my window because I want to make sure that it shows, my X values and my Y values. So on my X values, I have a minimum of 230 and a maximum of 530. So I'm going to go 200 on my X min, and then I'll go a little bit past my max, so 600, so that everything is represented from my X's. And on my Y's, it's all like in 15s. And I'm not going to, what I want to do is, I'm going to make my min 14, and my Y max 16. Let's see what that looks like. Right now I have it going by 1 unit. If I could change that, I will too. But let's go to stat plot and double check that the plot 1 is on, and double check that scatter plot is what I have, and my X list is now in L1, and my Y list is in L2. Right? That's why I label my graphs here. Now I can go to my graph and see what it looks like. And this is what it looks like. Now it's here. If I had anything pop up outside of this, then maybe I need to clear my Y equals clear, my algebra stuff, but I don't have anything I cleared before. This looks like a strong negative linear correlation visually. But let's do it mathematically. Let's actually get numbers and see. So right now it looks like there is a linear correlation and it looks negative. But let's see. Yeah. So again, stat plot is where I go to my stat graphs. I want to make sure it's on. I want to make sure it's statistics or scatter plot. And then my X list I labeled in L1 and my Y list in L2. And then I just go to graph. If it's not there, then you have to change your window. But it's there. Now, the rest of this, all the information that I need is in stat and tests and lin-reg t-tests. All this stuff is in lin-reg t-test is basically giving me everything. That part is just visualize. My X list was in L1, right? I want to remember where that is. And my Y list was in L2. Again, I always label that to make sure that I have that. And then you're not changing anything here. The frequency is 1, it's always going to be two-tailed because you want to know whether there is correlation or not. Leave that blank. Give me a second. And then this is my output. So what I want is my p-value to run my test. P-value is very small, 0.0099. So let me write my p-value, 0.0099. So you guys are determining if there is linear correlation, right? So you have a null hypothesis and an alternative. So either there is not correlation or there is correlation, right? There is or there isn't. The p-value for this test was approximately 0.0099, which if you're not given alpha, you're always assuming that alpha is 0.05. And so this is less than alpha, which means that I reject the null. I'm always looking to reject the null, right? Because if I want there to be linear correlation, then I have to reject the null. So here, I'm going to just copy and paste this and use that. I'm rejecting the null. So that means there's sufficient evidence to support the claim that there is a linear relationship or linear correlation between the amount of lemon imports and crash fatality rate. So I determined that there is linear correlation. Part 1 is done. Part 2, is it positive or negative? I know that it's negative. Why? Well, I looked at the graph. But let's go and numerically determine. Let's see what my linear correlation coefficient is for the sample. I'll go back to my calculator. I'm still here. I didn't even move this because everything else that I need is here under numeric t-test. I'm not changing that, but I'm scrolling down so that I get my R, which I expect it to be negative because it's negative linear correlation, and it's strong negative linear correlation. This is close to -1. Negative 0.959. Negative 0.959. This is a strong negative linear correlation. This is very close to -1. So we know it's a negative linear correlation. Graphically, it looked like that. Correlation coefficient is stating that. Now, based on that, let's actually determine my regression equation. Y hat representing my sample, my approximate output, my approximate crash fatality rate. But that is also here, right? A represents the y-intercept and B represents your slope. They give it to me. So I expect B to be negative, which it is, negative 0.0028. I'm going to take a lot of these digits. So let me copy that down. So I like to be in slope-intercept form personally. So negative 0.0028205x plus 16.49091. This is my regression equation to represent the situation. Obviously, if I didn't have linear correlation, then this regression equation would mean crap to me because it's a linear regression equation. So I want to determine that there's linear correlation before I even determine the regression equation. So now that I have it, what does this say? Find the best predicted crash fatality rate. Find Y. When there are 500 metric tons of lemon imports. When X is 500. Plug and chug. Y hat is approximately, I'm just going to plug it in. Basic linear stuff. Takes me back to algebra. So here we go. So negative, this was a negative 0.00. Oops, I forgot my number. Negative 0.0028205 times X was 500 plus my Y was 16.49091. see right here, 16,49,091. 16.49091. Let me check that number again. Make sure I got that. 49. Yep. Mm-hmm. Now, I mean, I could just straight up plug it in because my calculator is going to do order operations. So it's going to do multiplication and then addition naturally. 15.08. So the crash fatality rate would be approximately 15.1 because all the other ones are around the 10 years 10th. So around this one, 15.1 based on everything else. And that's all, folks.